What we have graphed here is the unit circle. Its center point is the origin, 0, 0, and its radius is 1 unit. This tiny, tiny circle is also very, very useful because it gives us a way to memorize and find 102 exact trig values. Okay, so we use this in math classes to help us find exact trig values. If I were to put the cosine of 30 degrees in my calculator, all it would give me is 0.866 blah 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 on until the end of the screen. But that's not the exact value. We can get that thing from this unit circle. Okay, so the outer bold circle, that's actually the unit circle there. I can tell that because this coordinate here is 1, 0. This is just a blown up version so that we can write all kinds of stuff in it. The inner circle, we're going to put degree measurements, and the middle circle here, we're going to put radians. The radians that match up with that. On the unit circle, on the outside, what we're ultimately going to do is we're going to find the xy coordinates of each of these points at each of those angles. Okay. So on this inner circle, what we're going to do is we're just going to find all of the degree measurements for these points. I've already done the first quadrant for you, the 0, 30, 15, 60, and 90 degrees. So what you should notice is that these lines right here are the same thing as these, just reflected across the y-axis. It's symmetrical. So between 60 and 90 degrees, this is 30 degrees. So all I have to do is take 90, add 30 to it. This is 120 at this point. Between 60 and 45, I've got 15 degrees. So I add a 15 degrees to that, and I get 135. Another 15 degrees makes 150. Obviously, at the halfway point is 180 degrees. Okay. Down here in quadrant 3, this is another 30 degrees, so 180 plus 30 is 210. Next one, add 15 degrees of that is 225. Add another 15 is 240. Now this time we want to add 30 degrees, and I get 270 straight down. Add the 30 again, I get 300. Add 15. 315, add another 15 is 330, and then 30 degrees brings us back to 360, which is a full circle. Okay, so now the middle one, what it is we're going to put radians there. Okay, so I'm going to go back to this other slide because I already have the degree measurements there. Maybe erase some of this stuff. Okay. And now let's just put the radian angle measurements on here. So we saw from a previous exercise that 30 degrees is the same thing as pi over 6. 45 is pi over 4. 60 degrees is pi over 3. 90 is pi over 2. If I want the rest of these, I just have to do the conversions. Like, for example, the 120 degrees. 120 degrees, open up my train tracks, 180 goes on the bottom, pi up top, cancel out the zeros. Common factor of 6, so this becomes 2 pi over 3. So at this point it's 2 pi over 3. And I do the same thing for the rest of that.